Hi all, welcome to lecture 6 of module 4 in database management system. Today we are going to the third form of normalization, which is third normal form and the Boy's Court normal form Bcnf. Okay, so till now we have seen the first normal form and the second normal form, and also we have discussed the problems related to these concepts. So let us continue with the third normal form. What is the third normal form? So a third normal form is based on the concept of transitive dependency. That is, the transitive dependency does not occur. So how can we identify a transitive dependency in 3NF by looking at the functional dependency? In the functional dependency, a non-prime attribute determining a non-prime attribute, if it is occurring like this, then we can say that it is a transitive dependency. Okay, so when a non-prime attribute is dependent on another non-prime attribute, then this is known as transitive dependency. Okay, അപ്പോൾ ഇങ്ങനെ ഒരു കണ്ടീഷൻ വരുന്നുണ്ടോ എന്ന് നോക്കിയാൽ മതി. It means that this is not satisfying a third normal form. Okay, if a non-prime attribute is functionally dependent on another non-prime attribute, then that condition is violating the third normal form rule. Okay, so let us see the definition. Let us see the definitions of third normal form. A relation schema R is in 3NF if it satisfies, the first rule is that it must satisfy 2NF. Okay, if a relation is in 3NF means that it must satisfy the rule of 2NF. That is it must be 2NF. The relation must be already in 2NF. Only after that we can check the next condition. What is the next condition? Transitive dependency does not exist. Transitive dependence should not be existing. So how can we identify a transitive dependency? A non-prime attribute is dependent on another non-prime attribute, then that is called a transitive dependency. Okay, these are two conditions. First condition is that it must be in 2NF, and the second one is that transitive dependency does not occur. So how can we identify transitive dependency from the set of functional dependencies? NPA, non-prime attribute determining non-prime attribute. It is not satisfying 3NF. Okay, so this 3NF can be also defined using the second definition, definition 2. So definition 2 states that a relation R is in 3NF if a non-trivial functional dependency X determines Y, then X must be a super key or Y is a prime attribute. Okay, these conditions we check here. We can check this condition, or we can also check this condition. That is, in a functional dependency, non-trivial functional dependency X determines Y, in which the X must be, that is the LHS must be a super key or a candidate key. Okay, LHS must be a super key or a candidate key, or this RHS must be a prime attribute. Okay, so when a set of functional dependencies are given, you just verify whether the LHS is a super key. Then you don't have to look at the RHS. You can directly say that it is 3NF. If the LHS is not super key or a candidate key, then you have to go to RHS. If the RHS is a prime attribute, then it is in 3NF. Okay, but a non-prime attribute determines non-prime attribute. This cannot be considered. This is violating 3NF. Okay, so these two conditions is actually giving the true condition for 3NF. That is, these two conditions satisfies 3NF. Clear? So you just remember these concepts. Okay, so this is the main concept. Okay, so X must be X in a functional dependency. X determines Y. X must be a super key or Y is a prime attribute. Clear? Let us see a problem. The same problem we have discussed earlier. Consider the relation ABCD with the functional dependency this one. Check whether the relation is 3NF. So we have to check whether the relation is in 3NF. Okay. So first we have to find the candidate key. In the question, candidate key is not given. So we have to find the candidate key, then extract the prime attribute as well as the non-prime attribute. Okay. So how can we find the candidate key? You take the closure closure of the relation, closure of the attributes of the relation ABCD. Okay, ABCD closure is ABCD itself. Okay, so ABCD is a super key. Now we will try to reduce this or minimize the super key by looking at the functional dependency. So look here, look at the functional dependency here. So here A determines B. Okay, since A determines B, we can eliminate B here. Okay, from this we can eliminate B. Okay, so since A determines B, then B can be removed from the super key. Clear? So the minimized version will be ACD. Okay, minimized version is ACD. So after this step, the super key will be ACD because B got removed. Clear? Next is check for any functional dependency. A determines C. A determines B, B determines C. A determines B, B determines C, which means A determines C. Okay, A determines B, B determines C. So A determines C. So C can be removed. Okay, so here we can remove C. Okay, so B is already removed. Now C is getting removed. Okay. Next step. We already got A determines C. We already got A determines C. Okay, from the transitive dependency we got A determines C. Now A determines C, C determines D. A determines C, C determines D. That means A determines D. Okay, so we can also remove D here. Okay, so the final super key is actually A. Okay, the final super key is actually A. Okay, so super key is actually A. Okay, if you want to confirm whether it is a super key, you just take the closure. Okay, the closure is containing all the attributes. Closure of A is what? First value is A. Second value is A determine B paranjittundu, so B. B determines C, so C. C determines D, so A, B, C, D. Since it is containing all the attributes of the relation, it is a super key, so A is a super key. Okay, since also this A is not having any subset. Since A is not having any subset, this can be considered as a candidate key. So A is also a candidate key. A is also a candidate key. Clear? Now prime attribute. From this I will extract the prime attribute. What is prime attribute? Prime attributes are members of candidate key. So prime attribute is A. Okay. Now you check whether any more candidate keys are there. For that you check whether the prime attribute is available in the RHS of the functional dependency. A, whether this A is occurring in the RHS of functional dependency. Here the RHS is B, so no issue. Here it is C, no issue. Here it is D, no issue. So we have only a single candidate key, which is A. Okay, so our candidate key is A, prime attribute is A, and non-prime attribute is B, C, D. What is non-prime attribute? The attributes which are not a member of the candidate key. Okay, candidate key illuള്ളത് A ആണ്. But not member of candidate key ഉള്ള ബാക്കി ഏതൊക്കെയാണ്? B, C, D. So B, C, D are not members of candidate key. Okay, fine. So we got all these values. Now we will check whether it is 3NF. Before that we will check whether it is 2NF. Okay, 2NF ആകണം എന്നുള്ളതാണ് first condition. So we will check for 2NF. So why we are checking for 2NF? Because a relation to be 3NF, a relation has to be 3NF only if it is 2NF, and later we check the conditions for 3NF. But 2NF ആണെന്നുള്ളത് first we have to check. So I am rewriting all the required values. These are the functional dependency, given functional dependency. Candidate key is A, prime attribute is A, non-prime attribute is B, C, D. Okay, A determines B. So A determines B. So here the LHS is candidate key or a super key. Candidate key determines B. Okay, candidate key determines B. So what does the second normal form says? If the subset of the candidate key is determining something, that will not be considered. So that violates 2NF. Here we are not considering. Here the A is not the subset of the candidate key. Here A is actually the candidate key itself. So A determines B, so no issue. It is actually satisfying 2NF. Okay, what is B determines C? What is B here? Non-prime attribute. C is also non-prime attribute. A non-prime attribute determining non-prime attribute is not an issue for second normal form. So it satisfies. Okay, so these two conditions satisfies. Now what about this one? C determines D. What is C? C is a non-prime attribute. What is D? D is also a non-prime attribute. A non-prime attribute determining non-prime attribute is not an issue for second normal form. So this is also satisfying. Okay, so these three, this relation is in 2NF. Okay, now we check for the 3NF. Now we check for 3NF. Okay, so what is the condition? So we have checked the condition for 2NF. Now we check for the condition of 3NF. Okay, so checking for 3NF, not 2NF, it is 3NF. Okay, we are checking for 3NF. So the same functional dependency and the same candidate key, prime attribute, okay, non-prime attribute, we have again took it down. Now we'll check A determines B. Take the first functional dependency, A determines B. Okay, what is the condition for 3NF? The 3NF condition is whether the LHS must be a super key. If it is not a super key, then RHS must be a prime attribute. Okay, so any of the conditions can be held. So here this A is actually a super key or a candidate key. Okay, it is super key as well as candidate key. So this satisfies 3NF. Okay, clear? So what is the condition for 3NF? The condition for 3NF is the LHS. I can write it down. LHS must be a super key or candidate key, or what? Or the RHS can be a prime attribute. Okay, any of these two conditions must be true. Okay, rest of the conditions will be considered as a false condition for 3NF. Clear? Next condition you check. Next condition is what? B determining C. What is B determining C? B and C are non-prime attributes. So this condition is violated. Non-prime attribute determining non-prime attribute is actually violating in 3NF. But here this satisfied in 2NF, but here it is a violation in 3NF. Also C determine D. C determine D is also a violation. Why? Because C and D are non-prime attribute. A non-prime attribute determining non-prime attribute is a violation for what? For 3NF. Okay, so this is the condition for 3NF. So how? So this is not a 3NF. Now we have to make this into a 3NF, third normal form. Okay, we have to make this relation into third normal form. So what we do is we will decompose this relation into 2. Okay, we will decompose the relation into 2. How we are decompose? Okay, no, we are actually decompose the relation into 3. So ABCD is our relation. Okay, so we are creating a separate relation for this one and this one. Okay, our one relation will be R1 of B comma C or R2 of B comma C with the functional dependency B determines C. Listen, see here R2, here it is considered as R2. We can also write this as R1, no issue. So R2 of BC is our one relation which is having the functional dependency B determines C. Okay, so here we have considered this B as a super key. But B is super key. We have made the B as a super key. Okay, since we have made this as a super key, what? A super key determining a non-prime attribute. A super key determining a non-prime attribute is a what? This is a true condition for what? 3NF. Similarly, see here, this is also a violation. For this, we will create a new relation R3 or R2, anything. Okay, R3, you can take R3. Okay, R3 with the attribute C comma D. Okay, R3 with the attribute C comma D with the functional dependency C determine D. Okay, this is our next relation. So here also we have made the C as a candidate key or a super key. Okay, so a candidate key determining a non-prime attribute is a true condition for 3NF. Clear? Now rest of the attribute, what is the attribute we are having? A to B. Okay, A to B can be accommodated in the this one. Okay, so A, B, C. Okay, so A in the relation of A, B, C can be having the functional dependency A determine C. Okay, so why we have included, we actually this functional dependency is not having C, then why we have included this C here? Because a C is actually a reference to what, reference to the other tables. So this C is actually referring to the table R3 and this B is referring to the table B, the R2. So B is a foreign key for this one, C is a foreign key for this one. Okay, so B is a foreign key that is referring to the primary key of R2, that is B. C is a foreign key that is referring to the primary key of R3, that is C. Okay, so this is our decomposed relation. So we have made this table into the 3NF. Okay, 3NF. Clear? So this is the decomposed 3NF table relation. Okay. Now another example. This is a little more complicated. Okay. Check whether the following relation is in 3NF. So our functional, this is our relation A, B, C, D, E, F. Functional dependency A determine B, C, D, F. B, C determines A, D, E, F. B determine F. D determine E. Okay. So here we will consider this. We don't have any. They have not given any candidate key. So we have to find the candidate key. So for that we will take A, B, C, D, E, F as the super key. Okay, A, B, C, D, E, F as the super key. So here we will take A, B, C, D, E, F as the super key. Okay, how to verify that A, B, C, D is a super key? We will take the closure of all this A, B, C, D, E, F. Okay, A, B, C, D, E, F, the closure atrayana A, B, C, D, and so this is a super key. Okay, now we can remove, or now we can deduce the super key into a minimum super key. Okay, look at this functional dependency. A determine B, C, D, E, F. A determine B, C, D, E, F. So that means that this B, C, D, E, F can be removed from here. Okay, so we can remove this B, C, D, E, F. Okay, so that is what it is written here. Since A determine B, C, D, E, F, so therefore B, C, D, F can be removed. So after removing B, C, D, E, F, the super key became A. So this is a super key. Since this does not have any subset, this super key A is also considered as a candidate key. So our candidate key is A, can be considered as a candidate key. Clear? So our candidate key is A, prime attribute is A, non-prime attribute is the rest of the attributes. This A കഴിഞ്ഞിട്ട് ബാക്കി വരുന്ന ഏതൊക്കെയാണ്? A, B, C, D, E, F. They are the non-prime attributes. Okay, fine. Next you have to check whether any more candidate keys, if more candidate keys are there. How to check that? You check whether this prime attribute is available in any of the RHS. No, it is not available here. Yes, here it is available. Here the RHS is containing A. What about this one? No. What about this one? Okay, so BC determining A, D, E, F. Okay, so BC determines A, D, E, F. A, D, E, F. Sorry, E, F. That means that BC determines A. BC determines A. Okay, so we can write BC determines A. Clear? So BC is determining A, D, E, F. Obviously, so BC will be determining A. Clear? So what we can do is, we can replace this A with the BC. We can replace this A with the BC. Okay, that will be our next super key. Okay, so since the prime attribute A is present in the RHS of BC, determine A, D, E, F. BC. Sorry. It is BC available. A, D, E, F. A, D, E, F. Yes, A, D, E, F. There will be more candidate key. So the super key A can be replaced with the BC. So this A can be replaced with the BC. So the new super key is BC. Now we want to check whether this BC is candidate key. BC can be candidate key. Okay. Since this BC is having a sub key, we have to take the closure of the sub key, closure of the subset. What are the subsets? B and C. Okay, so B are the subsets. We take the closure of the subsets B closure and C closure and check whether this closure is not a super key. If it is not a super key, then we can confirm that the BC is a candidate key. So what is B closure? B closure is B comma F, BF. The first value is B. Anything starting with B is F. Okay, so BF. So BF is not a super key. Our super key is A and BC, and A, B, C, D, E, F. These are the super key. So this is not a super key. What about C closure? Anything starting with C? Nothing is starting with C. Okay, so C is alone here. So this is not a super key. So therefore BC is the candidate key. BC is our candidate key, and prime attribute is BC, B comma C. Clear? So our candidate keys are, we are having two candidate keys. Okay, we are having two candidate keys. What? Now check any more candidate keys are there. Our prime attribute is BC. Our prime attribute is BC. Any more candidate keys are there? How to check that? Whether this BC is available in the RHS. Yes, here it is there. A determine B, C, D, E. Okay, A determine B, C, D, E. That is, we can write A determine B, C. That is, this BC can be replaced with A. Okay, BC can be replaced with A. So when we replace this BC with A, again the super key will be A. We have already computed that one. We have already computed that super key A. So it will be a repetition. So now we can stop here. We don't want to go further. We can stop here. Okay, we will stop this repetition. Super key repetition. We will stop. A is already, we have already found that A is a super key. Okay, so this will be again a repetition, so we can stop here. So we are having two candidate keys. What are they? Candidate keys are A, comma, BC. A, comma, BC. Okay, so we are having two candidate key A and BC. Okay, so BC is a candidate key. A is another candidate key. So A, comma, BC. Clear? Now the prime attributes are A, comma, B, comma, C. Non-prime attributes are D, E, F. Or non-prime attributes are D, E, F. Clear? So all these things we have received. Now we will check whether it is 2NF, and then we will check it is 3NF. Okay? Checking for 2NF. Again I have rewritten the functional dependencies. Candidate key. Okay? Candidate key is A, comma, BC. Candidate key is A, comma, BC. Prime attribute is A, comma, B, comma, C. Non-prime attribute is D, E, F. Okay. Now you check each and every condition. A determines B, C, D, E, F. A determines B, C, D, E, F. Is it satisfies 2NF? You check whether A is a super key or a candidate key. A is a candidate key. A alone is a candidate key. That's why I have a comma. Okay, A, B, C is a candidate key. A and B, C are candidate keys. So A is a candidate key. So this LHS is a candidate key. Okay, so that satisfies what? Our 2NF condition. BC determines ADEF. Next, BC determines ADEF. That also satisfies because BC is a candidate key. That also satisfies 2NF. Okay, B determines F. B determines F. B determines F. What about B determines F? What is B? B is not a candidate key. It is a subset of candidate key that violates 2NF. So in 2NF we have studied that 2NF condition violates if the subset of the candidate key determines a non-prime attribute. Okay, if subset of the candidate key is determining a non-prime attribute, then that condition will be violation. Okay. Then D determines E. What is D and E? D and E are non-prime attributes, so that satisfies 2NF. Only this condition is violated. Okay, so what we do is we will decompose the table. Decompose the table into two. Okay, one table will be having attributes B, comma, F with the functional dependency B determines F. Okay, so one table will be having. So this is our table. Okay, so this table with the functional dependency, this one, will be decomposed into these two tables. Okay, one table will be having attributes b comma f with the functional dependency b determines f. That is R2 b comma f with the functional dependency bf. So here we take b as here we consider b as the candidate key. Okay, candidate key. Clear? So this table the candidate key b ആയിട്ട് മാറി. So this condition will be satisfied here. 2NF will be satisfied. Clear? Now the remaining one. Okay, what are the remaining attributes here? A determines B, C, D, E, F. B determines F. What remaining attributes are? A determines B, C, D, E, F. B, C determines A, D, E, and D determines E. Okay, so actually we can remove. See, this F has been moved here. Okay, this B determines F has been moved here. So we don't have this F anymore in this functional dependencies as well as in the attribute of the table. So this first table will be having only A, B, C, D, E up to A, B, C, D, E. F ഇവിടെ വേണ്ട. Why? Because F has been completely moved to this one. Second. Okay. So A, B, C, D, E with the functional dependency A determines B, C, D, E. A determines B, C, D, E. F can be removed. Also B, C determines A, D, E. B, C determines A, D, E. Okay. Then D determines E. Clear? If we are writing F here, then we have to include F also in the attribute. Okay, since I have removed this F from this attribute, we can remove this F also from here. Okay, we don't require this F here. Then you will have a doubt. Then how will we connect this and this table? Using B we can connect. Using B. So this B will be the foreign key for this table. For this table R2. Okay. So this B can be underlined. This will be the super key or the candidate key, which will be, so this B will be the B in R1 will be the what? The foreign key for this one. Okay. So this is how we can decompose the table. Clear? Now how can we show that this is 3NF? Next, we have already told, we have already checked 2NF and decomposed the table. Decomposition took place by two tables. And the table decompose. Next we will check for 3NF. What is the condition for 3NF? 3NF again we will take the functional dependencies. Okay, since we have to take, we have already decomposed into two tables, we will take the first decomposition table. Okay, first this decomposed table we will take and check for 3NF. This here also we will check for 3NF. Okay, separately we will check. Okay, I will first we will take this one. Okay, I have took R1 A, B, C, D with this functional dependency. Okay, I have taken. So the candidate keys are same. Candidate key is this one, prime attribute this one, non-prime attribute this one. Okay, so A determine B, C, D, E. A determine B, C, D, E. Is it okay? Because we have set this A as the candidate key. Okay, so this is the candidate key. Okay. So look at here. So this LHS. So LHS is what? LHS is a super key or a candidate key. So here LHS is a candidate key. So it satisfies 3NF. Okay. Since LHS is a 3NF, we don't have to look at the RHS. Okay. LHS 3NF, LHS super key or candidate key ആണെങ്കിൽ നമുക്ക് RHS നോക്കേണ്ട കാര്യമില്ല. Okay. So this satisfies 3NF. Clear? Again look at here BC. Since this BC is a super key or a candidate key. BC is a super key or a candidate key. So here the candidate keys are A, BC. So BC is a candidate key or a super key. Since the LHS is a super key or a candidate key, we don't have to go further. We don't have to look at the RHS. It satisfies 3NF. Okay, but the reason we did it. Next, D determines E. We'll take D determines E. Okay, what is happening in D determines E? Where is D a super key or a candidate key? No, D is a non-prime attribute. Okay, non-prime attribute determining non-prime attribute. This cannot be considered in 3NF. Non-prime attribute determines non-prime attribute cannot be considered in 3NF, so it is violating. Okay, so this has to be decomposed. So this table is not in 3NF. Okay, so this R1 has to be again decomposed. R1 we will decompose. Okay, what about R2? R2 does require any decomposition? Look here, R2BF. These are the candidate key. So here we have the candidate key is actually not ABC. This candidate key here we have considered it as B. Okay, but the candidate key is B, and we have taken it as B. Okay, so the prime attribute is B. Prime attribute is B, and non-prime attribute is F. Non-prime attribute is F. B determines F. Clear? So since the B is a super key or a candidate key, this is satisfying. Okay, this is satisfying. Clear? നമ്മളത് എന്തുകൊണ്ട് ബി ഇവിടെ കാൻഡിഡേറ്റ് കീ ആയി? നമ്മൾ ഡീകമ്പോസ് ചെയ്ത് കഴിഞ്ഞപ്പോഴത്തേക്ക് when you have decomposed the table into R2, we have made this B as super key or candidate key. Okay, so here the candidate key is B, and the prime attribute is B, and non-prime attribute is F. So B determines F satisfies the what 3NFs, because LHS is a super key or a candidate key. Okay, ഇവിടെ decomposition വേണ്ട. So decomposition has to be done here. D determines E. That is in R1 the table has to be decomposed. Clear? അപ്പോൾ decompose ചെയ്യുമ്പോഴത്തേക്ക് എന്ത് ചെയ്യും? One table, this will be further decomposed into a table which contains attributes DE. Okay, R11 and R12 is having decomposed version DE with the functional dependency D determines E. Okay, this R1 ABCDE with the and R2 BF is decomposed. So this is decomposed. Okay, so this is decomposed into like this. R11 in the R1 in the decomposed, we have made it into R11 and R12. R11 and R12. Clear? So R12, what does R12 contains? So R12 contains B determines F. B determines F in the functional dependency. So it contains attributes B comma F. So R12 contains attributes D comma this R1 contains the violated version is D determines E. Okay, so R11 contains one relation having attributes D comma E with the functional dependency D determines E. Okay, so the rest of the thing will be applied in the R11. Clear? So R11 A, B, C, D. Now we don't require E here because E has been already transferred here. Okay, so A, B, C, D with the functional dependency what A determines B, C, D. Our functional dependency was A determined B, C, D, E. A determined B, C, D, E. From that we have eliminated E. Okay, so A determined B, C, D is required. A determines B, C, D, and B, C determines A, D, E. E നമ്മൾ കളഞ്ഞു. A is eliminated. So B, C determines A, D. Okay, clear? If you are providing this, if you want to include this E here, then we have to include this E in the attribute level also. Since we have removed this E from here, we can remove from E from this functional dependency also, because that E has been already shifted here. Okay, then how can we attach this and this table? By our attribute D. Okay, so D will be the foreign key which will be referencing to this table. Okay, so here B will be your foreign key that will be referring to this table. Okay, this is our decomposed table after what? 3NF. Clear? Clear? So this is a university question. Okay. Next question. Next concept is Boy's court normal form, Bcnf. We are moving to the next condition, Bcnf. So 3NF condition all of you are knowing. Clear? So Bcnf is stricter than 3NF. It is more stricter than 3NF. The conditions we have permitted for 2NF will not be permitted in 3NF. Okay, what are the conditions that you will check now? Every relation is in BNF. Every relation in Bcnf is also in 3NF. However, a relation in 3NF is not a Bcnf. Okay, that means that a relation in Bcnf, a relation in Bcnf can be in 3NF. Okay, but a relation in 3NF cannot be in BCNF. അതായത് ബി സി എൻ എഫ് ആയിട്ടുള്ള ഒരു റിലേഷൻ നമുക്ക് 3NF ആയിരിക്കും. ബി സി എൻ എഫ് ആയിട്ടുള്ള റിലേഷൻ വിൽ ബി ഇൻ 3NF, ബട്ട് എ റിലേഷൻ 3NF മേ നോട്ട് ഹാവ് ടു ബി ഇൻ BCNF. ഓക്കെ, അത് നമ്മൾ ചെക്ക് ചെയ്താലേ പറയാൻ പറ്റുള്ളൂ. ഓക്കെ, so let us see what is the condition. We can see definitions. A relation R is in BCNF if whenever a non-trivial functional dependency x determines y, then x is the super key of R. Okay, so we are having a relation schema R which is a non-trivial functional dependency. This x determines y is non-trivial functional dependency. Then x is a super key. Non-trivial and all we have discussed previously. Okay, so it is an x determines y is a non-trivial functional dependency. Then x is a super key. Clear? So what is the condition we have seen in 3NF? 3NF we have seen two conditions. What are the conditions? If x determines y, if a non-trivial functional dependency x determines y ആണെങ്കിൽ we can have two conditions. Okay, what is the first condition? X is a super key. X is a super key. Sorry, x must be super key. Or what is the condition? Y or the RHS can be a prime attribute. That was the condition for 3NF. But here we have eliminating this second condition. We are eliminating this second condition. Okay, ഈ second condition നമ്മൾ എന്ത് ചെയ്യുന്നു? ആ or condition we are eliminating here. അത് eliminate ചെയ്യുമ്പോഴത്തേക്കും this becomes what? 3NF. So in 3NF we are having only one condition. What is the condition? X is only super key. Okay, in a trivial functional dependency x determines y, the x or the LHS must be super key. That is the only condition. Okay, in 3NF we saw that x is a super key or y can be or RHS can be prime attribute. അതല്ലേ നമ്മൾ കണ്ടത് കേട്ടോ. x is a super key or y is a prime attribute. Okay, in BCNF this condition is removed. This will be removed. Okay, this condition is being removed. Okay, so this is the condition for our 3NF. X is a super key. Clear? Now let us check another problem. Consider a relation RABC with the function dependency A determines B, B determines C, C determines A. Okay, first we have to find the candidate key. ABC closure, ABC is the candidate key. Now we can minimize this functional dependency. A determines B, so B can be eliminated. So we had A, B, C as a super key. So since A determines B, we can eliminate B. Okay, any functional dependency is there? A determines B, B determines C. So that means A determines C. A determines B, B determines C. That means A determines C. Okay, A is determining C, so we can remove C also. Okay, so our super key became what? A. It is minimized to A. Okay, since we have only one member as the super key, there is no subset. So A can be candidate key. A can be candidate key. A is the candidate key and the prime attribute is A. The prime attribute is A. Okay. Now any more functional dependency exists? Any more candidate keys existing? Look at the RHS of the functional dependency. Here no. Here no. Here S. Here S. Here this functional dependency is having A as the RHS. Okay. So C determines A. C determines A. That means that we can replace A with C. A with C. So there is more the candidate key because A is available in the RHS of the functional dependency. C determines A. So A can be replaced by C. So the new super key is C. Okay. So C can also be a candidate key. C can also be a candidate key. Clear? So prime attribute is C. Okay. Now any more candidate key is there? Is there any C available in the RHS? Yes, here it is there. Here it is there. Okay, so what? So that means that B determines C. That means C can be replaced with B. B determines C. So C can be replaced with B. So there are more candidate key because C is available in the RHS of the functional dependency. B determines C. So C can be replaced by B. C can be replaced with B. So new super key is B. So B is a candidate key. B can also be a candidate key because it does not have any subset. Okay. Any more candidate keys are there? Any more candidates? The prime attribute is A. So is there any prime attribute available in the RHS? Yes, B is there, but this is A determines B. So B can be replaced by A. B can be replaced. This B can be replaced with A. That means that again it is A we have already taken as the super key. So it will be a repetition. So we can stop here. So our candidate keys are what? A is a candidate key, C is a candidate key, and B is a candidate key. So three candidate keys, A, B, C are the candidate keys. Okay, prime attribute are this one, A, B, C. Okay, so the candidate keys are A, comma, B, comma, C. You can put comma. We are having three candidate keys. See here we don't have any prime, non-prime attributes. All are prime attributes. Okay, we don't have any non-prime attribute here. Okay. Now we check for the B. We are checking the Bcnf directly here. We are not going for 2NF or 3NF. We are directly going for the 3NF. Checking for 3NF. Okay. If the question they are asking is if we check for Bcnf, then you can directly go. No issue. You can directly check whether this is 3NF. Okay, that is enough. Clear? So check for Bcnf. You don't have to waste time by checking 2NF, 3NF and all. You can directly check for Bcnf. Okay, that is a correct way. Check for Bcnf. A determines B, B determines C, C determines A. Candidate key is A, B, C. Prime attribute is A, comma, B, comma, C. Okay. So candidate keys are A, comma, B, comma, C. Okay. Now A determines B. A determines B. What is A? A is a super key or a candidate key. So this is satisfying. This is satisfying. A is a super key, that is satisfying the Bcnf condition. Next is what? B determines C. What is B? B is also a candidate key. Okay, B is also a candidate key. അതുകൊണ്ടാണ് ഞാൻ ഇവിടെ കോമ ഇട്ടത് അതുകൊണ്ടാണ് A, B, C ഒരു candidate key അല്ല. A, B and C, three are candidate keys. Okay. So B is a super key. So B can be considered as a super key. Now C determines A. C determines A. Okay, so C is a candidate key or a super key. So this also satisfies. This also satisfies Bcnf. So this relation is in Bcnf. We don't have any decomposition required. Okay. So this is the method of computing whether the relation is in 3NF, Bcnf, 2NF or 1NF. Okay. If from 2NF onwards we need to compute the candidate key. In the first normal form we need to verify the values whether any domain is having multi-valued attribute. In that case that has to be eliminated. From second normal form onwards we have to find the candidate key. How to find the candidate key we have already discussed. In university question they may also ask to find the candidate key alone. Okay, that will also be a university question. Okay, so this is how the condition goes. So in 3NF, so in the 2NF, what was the condition? The subset of candidate key must not determine a non-prime attribute. That was the condition. 3NF condition was, we had two conditions, whether the LHS must be a super key or a candidate key, or RHS must be a what? RHS must be a non-prime attribute. Okay, but Bcnf is not like that. Bcnf says that the LHS must be a super key. Okay, LHS must be the super key. RHS they are not going. They are not looking at. Only the LHS they are considering. LHS must be strictly what? A super key or a candidate key. Okay, they don't have any OR condition. Clear? So these four concepts, first normal form, second normal form, third normal form and Bcnf. It is very important question. Problems will be coming. They won't ask any theory questions, only problems will be coming based on this normalization concepts. Okay, so study well and do problems repeated to this related to this. Okay, we will be doing repeated problems and we will be discussing more university questions in the forthcoming classes. Okay, thank you.